Hello, guys. I'm here again to give you keep you company this Saturday. My name is Joseph Ejike Oji. Today our topic of discussion will be empirical rule and their applications. Empirical rule is basically a way of showing how to use standard deviation to describe a variation. And it is based on the fact that, it can be used only for data sets that are normal or symmetric or bear-shaped. Now, before we start, let me share my screen with you so that because I'm sure you'll be asking yourself, what the hell is he talking about? So I'm gonna open my screen, share my screen with you, and then we can begin working on those. Empirical rule. Make sure that you can see my screen, and then we can begin. I think you can see it now. Okay, like I explained a few minutes ago, we use empirical rule to show how we can use standard deviation as a measure of variation, to describe variation. And then it is basically more or applicable to data sets that are considered to be normal or bear-shaped or symmetric. Now, according to the empirical rule, it says for any data set or for data set having a distribution that is approximately bear-shaped or symmetric or or normal, the following properties applies. 68% of all values fall within one standard deviation of the mean. 98% of all values will fall within two standard deviation of the mean. And 99.7% of all data values will fall within three standard deviation of the mean. So normally we express this rule using this simple formula here: mu plus or minus s times standard deviation. Where this s represents the number of standard deviation, that we're talking about. This is the standard deviation itself here, this delta sign, but this s represents the number of standard deviations. Of course, from the various lectures we have, you know that this symbol here, mu, represents the mean or the average. Now, let me give you more background about this empirical rule. First of all, I have already explained that it is used for data set that is considered to be normal or symmetric. Now look at the chart here, the diagram. I call it the empirical rule diagram. You can see what we are talking about. For 68% lie within one standard deviation. You can see the mean minus one standard deviation. Usually in the algebra, when it is 1x or 1y, we don't write it, we just write x or y. So the same thing here, one standard deviation, we just write this delta. This is the mean right here. This is one standard deviation away from the mean on the left side. This is mean plus standard deviation, which is one standard deviation away from the mean on the right side. So this right side, we also call it the upper side, upper end. The left side is also called the lower end. Now, for the one standard deviation, you can see it right here and here, and you can see the 68%. Now, empirical rules say that 95% of the values fall within two standard deviations of the mean. This is two standard deviation on the left side. See, mean minus 2 times standard deviation, which is 2 standard deviation away from the mean on the left side, which is the lower end. Here we have the mean plus 2 standard deviation, on the right side, which is the upper end. And if you look at it from here, you can see the arrow can show them, and it is 95%. Now, the third rule says about 99.7% of all the values fall within 3 standard deviations. You can see on the left side, mean minus 3 standard deviation. See the 3 right here on the left side, which is the lower end. So it's 3 standard deviation away from the mean on the left side. Here you can see the mean plus 3 standard deviation, which is 3 standard deviation away from the mean on the right side, which is upper end. I also, listed how many standard deviation they are on the left side and right side here. So this rule is set on stone. You can't change it. There are proofs for it, but that is not our focus today. Our focus is how to use this rule to solve some questions that you can see in the classroom or in exam, and so on and so forth. Now, there are a few key points that I want to explain before we proceed. For an empirical rule, those data values that are within 2 standard deviation, that is from here to here, are considered to be normal. And I give you an example. The normal blood pressure for an adult, we have the normal range, So anything above that is not normal, or below that is not normal. How about the blood sugar? Anything above that is not normal, or below that is not normal. How about this? The income, the average income of median income. We usually say median income of a civil servant. Of course, this is relative. Some states they make more, but in some states they make less. But there's a normal range we have that we say this is a civil servant, this is how much he makes. It's become normal. Above that, then something is wrong, or below that, then it's not normal. So the data values that fall within 2 standard deviations of the mean are considered to be normal or usual. So, see, but anything above 2 standard deviation, like 3 standard deviation, or of the mean, is unusual. And I'll give you an example. Suppose I come to a classroom, let's say 3rd grade classroom, and I brought somebody, an adult who is 18 years, and put the person in that class and give a test based on the 3rd grade curriculum. That adult that I brought in will score very high. That is not normal, So it's unusual. And I will give even more examples. I'm sure you must have heard of 6 sigma, which is like instead of 6 standard deviation. That means a measure of high quality. In 6 sigma, that means unusually high quality products go to that 6 standard deviation beyond, above or below the mean. Okay, I think you get the point. So means that data value that is within 2 standard deviation are the usual or normal. Then those that are above 2 standard deviation are unusual. Those that are above 3 standard deviation are considered very unusual, like the 6 sigma, right? I explained. 6 sigma, actually, why do we call it sigma? Because of this symbol here, the delta symbol, or some call it sigma symbol. I'm sure you get the point by now. So I have this summarized in a table. When it's 1 standard deviation of the mean, use mean minus standard deviation for the left side or lower side, mean plus standard deviation for the right side. When it is 2 standard deviation from the mean, that means S is 2, use mean minus 2 times standard deviation on the left side, and mean plus 2 times standard deviation on the right side. So when it is 3 standard deviation from the mean, okay, use mean minus 3 standard deviation on the left side, mean plus 2 standard deviation on the right side. Okay, now I have given you the background. Let me show you how simple this can be used in solving questions. Our first question today will be this. It says, in a survey conducted, that is question 1. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States, those men that are aged 20 to 29 years, was 64.2 inches. And the standard deviation is 2.9 inches. Estimate the percent of women whose heights are between 58.4 inches and 64.2 inches. So estimate the percentage of women. Assume that the distribution of the women's height is bear-shaped. See, this is very, very important. the equation must say this. That is how you know that you will use the empirical rule. So he said, assume that the distribution of the moment side is bear-shaped. That means a typical empirical rule. So let's do it. Solution. The first thing you do is to draw the curve, then put the numbers in, then calculate the values for all these formulas here. See? Use them to calculate the values. Then you can get your percentage. So first of all, you see that the mean is okay. I'll take you to my formula. Some characters I can't get here, but I think I can get here. The mean is 64.2 inches. The standard deviation, give me 1 minute. Make sure you're seeing this. I want to make sure you're seeing this. Okay, good. And the standard deviation is, okay, I think I have the symbol here from standard deviation. Here is 2.9. So you can see right, 2.9 inches. 2.99 inches. So, like I said, the first thing you do is to draw the curve, the normal curve, get the values for what is curve here, get the values for mean minus standard deviation, mean plus standard deviation, mean minus 2 standard deviation, mean plus 2 standard deviation, then mean minus 3 standard deviation, and mean plus. So use the formula to get the numbers for each of these formulas here, and then put the percentages here, then you can be able to answer the question. So let's draw the curve now. So I'm gonna 1 minute, let me make sure you're seeing this again. Okay, good. So I'm gonna go here, insert, so I can draw the curve. It's gonna look like this. I'm gonna make it as simple as I can. Okay. Yeah. Now I'm not a good drawer, but I'm gonna let me try and do this. Okay. Let me draw it again. This kind of thing is better when you're using a freehand sketches. But like I said, I'm gonna do my best here. Okay. Now I'm gonna put I think I'm gonna move this down so that we can have enough room for this. Okay, I'll move it down. Let me move it down, solution down. Next page, so we have enough room for the curve. Okay, insert it. Now I go here. Then I put in the x-axis for this. Now we are told that the mean is 64.2. So I'm gonna put that one first. 64.2 inches. And you can see it from the original empirical curve that we have here. See, the mean is right there. And from there, we can get this mean minus standard deviation and mean plus standard deviation. Okay, so we have it here. So I'll put the mean, the line for the mean here. Okay. 64.2. Okay. Now, according to the empirical rule, if you remember, it says here that 68% lie within 2 standard deviation. Now, because we have 2 sides, left side and right side, all we have to do is to divide this 68% by 2 so that we get the value for the left side and the value for the right side. Okay, so let us do it. And then now I'm going to put the line first. I'm going to put the first line. And then the second line, which represents 68%. Now, to get 68% by 2, 68% divided by 2, we can get it using the calculator. Remember my calculator we normally use? It's called the decimals. Okay. Excuse me, my mistake. Give me 1 minute. I want to make sure you're all seeing this. This is where we are. Okay. So I'll take you there so you can see the decimals. I'll take you to here. So we have decimals.com /scientific. It's a free calculator. It's a free scientific calculator that anybody can use. Press on it, it will come out. And this is it right here. You can see decimals. So 98% will be 98 divided by 2. Sorry, not 98. It's 68% for the one standard deviation is 68%. 68 by 2 give us 34%. So on the left side, we have 34%. On the right side, we have 34%, which make up the 68% according to the empirical rule. So I'm going to take you back there so you can see the work. 34% on both sides. So we have here 34%. And here, okay, I missed my mistake. Okay, here. Oh, excuse me. Here, 34%. So we'll continue with that. This is for the one standard deviation of the mean. Now let's get the one for 2 standard deviation of the mean. So I'm going to put the lines first. Okay, we'll have it here. Okay. Another one here. To make it, so I'm going to make this line a little bit shorter and put it right here so that I have enough room to write. Okay. Now, what does the empirical rule say for this one is one standard? What does it say for 2 standard deviation? If you look at our chart for empirical, it says that say 95% is for 2 standard deviation. Now we already have 68%, so we cannot count it twice. So we do 95% minus 8%, and whatever is left will be what we're gonna put here. Okay. So we're gonna do. We'll take it to decimals. I have so we're gonna have 95 minus 68% that we already have. Okay. Now, since we are talking about left side and right side, so we're gonna divide by 2. Give us 13.5% on the left side and 13.5% on the right side. So I'm gonna take you back to our work. Okay. And then we scroll down 13.5%, I believe. So we have 13.5% here on the left side. At 10.5% on the right side. Now, we have the 2 standard deviation. Now, the last one is the 3 standard deviation. What did empirical rule says? It says that for 3 standard deviation, which is from here to, we have 99.7%. Now, we already have 95%. See? So we don't have to count because we are looking for only this part and this part. So we're going to subtract 95% from 99.7%. And since we're looking for two sides, we can now divide by 2. So 99.7%, I will take it to decimals. So that we have 99.7% minus 95%. Okay. Divide our answer by 2 because we're looking for two sides, left and the right side. 2.35% on both sides. 2.35%. So take it back. 2.35%. So we put the line, first of all, I'm putting 2.35%. Okay, here. I think I'm going to move it all the way here. My diagram is not as good as they have in the book, but it's good enough, I believe. At least you get the point I'm trying to make here. 2.35% for the that's 3 standard deviation. So 2.35%. Okay. They have 2.35%. Okay. So this one. Oh, my mistake. You just same line. 2.35%. Note that in a normal drawing, this side will be equal to this side. It's just my drawing. I'm not too good at drawing with computer. So, right, this side and this side, and they are the same. Just like you have it in this chart here, they have to be the same on both sides. So, but I believe that this is explanatory enough. So once we have gotten their percentages, next thing that is left is to use the formula to get the numbers that will be here, 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 and here, here, here. Once we have that, we can now be able to answer the question. Remember the question was, what percent, to estimate the percent of women whose height are between 58.4 inches and 64.2 inches. So now we already have our mean. The first one we're gonna do is for one standard deviation. According to what I showed you on the table, if you want standard deviation, use mean minus, standard deviation, and mean plus standard deviation. Yeah, one standard deviation. So in this case, we have mean. Just 1 minute. Let me make sure you're seeing this. Yep, you're seeing it. So for here we have, okay, for this side, for the left side, we have it this way. Mean minus standard deviation. So mean minus one standard deviation. Mean minus one standard deviation will be equal, let me bring it down a little bit, equal to, our mean is 64.2. And the standard deviation, we are giving that as 2.9. And this is for the left side. Okay. Remember, this is left. Right. Okay. So now from decimals, we can get this. Let me write this down on paper so I can work it out. And I think I can use this. We have mean minus standard deviation, which is 64.2 minus 2.9. So from our decimals, now we have 64.2 minus 2.9. That gives us 61.3 inches. So you can put it right there. Okay. got 61.3 inches. Then for the right side, which is this side here. So in that case, we have the same thing, except that we have it as a plus sign. So I'm going to just copy it. We have mean plus standard deviation. Excuse me, plus standard deviation. So you have mean plus one standard deviation, which means equals 64.2 plus 2.9. And that's from decimals. You can just get it. Since we have it already in the formula part in the decimal, all we need to do is to change this to plus sign. Like it was 67.1 inches. So we go back and put it 67.1 inches. Okay, 67.1 inches. So on the left side, we have 61.3. Okay. On the right side, which is this one, we have 67.1. So we do the same thing for 2 standard deviation and 3 standard deviation. Once we have that, we almost finished our answer. So now I'm gonna copy it. So we have done for the 1 standard deviation. Let's look at for the 2 standard deviation, which is here, mean minus 2 standard deviation, then mean plus 2 standard deviation. So you can have it here. The right side, so left side equals, we have mean minus 2 standard deviation, which is minus 2 times standard deviation, which is mean is 64.2 minus 2 times the standard deviation of 2.9. Yeah, equal. So we can look at it in decimals. Let me write it down: 64.2 and 2 times 2.9. Okay. So I'll take you to decimals. We got 64.2 minus 2 times standard deviation of 2.9. The closest give me 58.4. 58.4. So I'm taking it back here. We got 58.4. 58.4. Then we'll repeat the same thing for the left side, except that this time we use a plus. So I'm just going to copy it and paste it here, then change it to plus sign. This is change it to right side, right, and then this to plus sign. Okay, and then this is the plus sign, and then let's see what answer we'll get. I'll take it to decimals. Decimals. So we add plus sign here. Get plus. We get 70. 70. So I'm going to put 70 here. Take you back. 70. What am I missing here? Let me see, 64.2 plus 2 times 2.9 is 70. Okay. Yep. I'll make sure I have the mean and standard deviation correctly. Yep. 4.2 plus 2 times. Okay. Right. 70. We have 70. Now, let me write it down here. So we have the left side of here as we got, let's start at 58.4. Okay. Okay. The right side is 70. 70. Okay. Now, next is for trace standard deviation, we repeat the process that we use mean minus trace standard deviation for the left side and mean plus trace standard deviation for the right side. So we have it here as for the left side is the same thing except that now we change this to 3. Okay. Mean minus, instead of 2, we use 3 now. 3. And then change this to 3. Let's see what answer it will give us. Write it down. 64.2 minus 3 times 2.9. 64.2 times, okay, let me take you to the decimals. We have 64.2, okay, minus 0.2, minus, instead of 2, we're going to use 3 this time. You have 55.5. Okay, so I'm taking it back. We have 55.5. The left side, 55.5. Okay. Now for the right side, mean minus now become plus 3 times standard deviation plus, okay, 3 times standard deviation. Now let's see what answer it will give us. I will take it to decimals. Okay. So make it plus sign. You can see that it is 72.9. 72.9. Yeah. I'm taking it back there and then put 72.9. 72.9 inches. So now I'll go to the chart, have 55.5 on the left side. So I'm gonna, okay. Then on the right side we have 72.9. 72.9. Okay. So we have this here, 54. Okay. Now with this, we're ready to answer the question. The question says, what estimate the percent of the women whose height are between 58.4 inches and 64.2 inches? So we're talking about 58.4 inches, 58.4 inches to 64.2 inches. Okay. Look at here. See 58.4. This is 62.4. So like the percent of women, I'm gonna percent of women whose heights are between 58.4 inches to 64.2 inches is equal. So you can see it from here. Okay. You can see from here that this is 58.4 inches. It's between 58.4 and 64.2. You can see the line here. Of 58.4. You can see the line right here. Move it closer so you can see what I mean by that. See? I think this So this is the line for 58.4, and this is the line for 64.2. You can see that the percent is from this one and that one, which is 13.5% to 13.5, 13.5, and 34%. So these are the percent of women whose height are between 58.4 and 64.2 inches. So we add the two of them, you get the answer. So we're gonna be equals 13.5% plus 34%, which is equal. So from the decimals, even without going to decimals, we can add this together. 1 plus 3 is 4. Then 3 plus 4. So let me use decimals because, okay, I'll do both. Then 3 plus 4 is 7. Then 0.5% stay the same. Okay. Now, I will take you to decimals for those of you who are confused about how I get this answer. I go to decimals, and then you can see that 13.5% plus 34% is 47.5%. So 47.5%, which is the answer we have, 47.5%. So the percent of women whose height are between 58.5 inches to 64.2 inches, based on what we have here, and here, so this two from here to here is 13.5% plus 34%. That gives you 7.5%. So the hard part is just getting this chart and putting this number, getting these numbers. Now, but since we already have this chart, remember I said that these values for empirical rule are set on stone, so you don't change it. So the next one we're gonna do, I'm just going to copy this chart. The only thing that will change is the formula. These numbers are the bottom. So I'm gonna copy this and paste it for the next one. Make it easy for us, okay? So the answer again is 47.5%. Hope you enjoy this. Okay, let's try another way. Let's try another way that we can apply empirical rule, which is for question 2. It says, past results from National Health Survey suggest that the pulse rate of women, and pulse rate means heartbeat per minute, excuse me, have a mean of 76 beats and a standard deviation of 12.5 beats. Assume that this distribution is symmetric. Again, remember that statement of symmetry. Yeah. Find the minimum and the maximum usual pulse rate of women. Now, then this says determine whether this pulse rate of 110 should be considered unusual. Let's see. Solution. Okay. In this case, the mean is 76, and the standard deviation is 12.5 bits. So it says part A says find the maximum and minimum usual rate, pulse rate for women. Usual, it says use the word usual. Now, this is part A. Let me write it down. Part A. If you remember, when I was introducing this lecture, I showed you that the usual rates, anything that is, look at my chart here, it said data entries that lie more than 2 standard deviations from the mean are considered unusual. So anything that lies below 2 standard deviations or anything that lies in the 2 standard deviation is considered usual. So like here, this is 2 standard deviation. This is 1 standard, 3 standard deviation. Then from here, from the 2 standard deviation is the usual rate. See? Anything that lies above that is unusual, like 3 standard deviation is unusual. So that means we're going to use this formula here for usual because it says usual rate. So when I'm saying usual, some people might be asking, what is he talking about? Say, this is what I mean, like usual rate. So we use two standard deviation for anything that fall within two standard deviation is considered usual or regular rate. So for usual rates, we use two standard deviations from the mean. Okay, so that means minimum will now becomes minimum rate will become okay. For the two standard deviation, we use the formula that it says mean minus two standard deviation for the minimum, and mean plus two standard deviation for the maximum. So we have it here as make sure you're seeing all this. Good. Okay. As minimum will be, we have symbols mean minus 2 times standard deviation, which is our mean is 76. Because it says 76 right here. Minus 2 times standard deviation of 12.5. So we can go to Desmos and get it. Okay. I have 76 minus 2 times standard deviation of 12.5. So I'll take you out to Desmos. So we got clear all 76 minus 2 times standard deviation of 12.5, giving us 51 bits per minute. 51 bits per minute, so that's 51. So 51 bits per minute. And the maximum gonna be the same thing, but then we just have to change this minus sign to plus sign. So let me just copy it. It's right here. I'm gonna clean this. So we change this to plus sign and change this to plus sign. Yeah, let's see the answer it will give us. I'll take it to Desmos again. So when I change this to plus sign, give me 101 bit per minute. Okay. So it's gonna be 101 101 bit per minute. So that means that it said find the maximum usual pulse rate for women. So any women that have this, based on this data set, any woman that have this bit of 51 to 101 bit per minute is considered normal or usual. Okay. So we have answered part A. Part B says, now it says determine whether a pulse rate of 110 bits be considered unusual. So 110, if you look at it, the usual rate bit is 51 to 101. So 110 is bigger, is outside the range, so it is unusual. A pulse rate of 110 bits, okay, a minute is unusual because it doesn't fall within the range. It falls outside range, the usual rate of 51 bit per minute, 51 to 101 bits per minute. See, it's unusual. If it is 50, it's also unusual because it doesn't fall within that range. Okay. I hope you enjoyed this one too. So this is one of the ways we can apply empirical rule. There's another method we can use, where you can apply it, which is take substitute equation, but part 3 equation says the mean monthly utility bill for a sample of household in Baltimore is $70 with a standard deviation of $8. Between what two values does 95% of data set lie? Assume that data sets have a normal or bell-shaped distribution. That this tells us exactly what we are looking for. Now, but it says, but before we start solving it, solution, we have that the mean is $70. The mean is $70, and standard deviation is $8. Now, part A says between what two values does 95% of data value lie? Now, empirical rule already told us that if you look at the empirical rule here, it said that 95% of data value falls within 2 standard deviation of the mean. See, that makes it answer simple. So that means we're going to use 2 standard deviation of the mean formula here. So that means we have, according to empirical rule, okay, 95% of data values falls within 2 standard deviation. So now we can use this. So the first the first value, the minimum value will now become mean minus 2 times standard deviation, okay, which is mean of $70 minus 2 times standard deviation of $8. So this we can get from let me write it down. 70 minus 2 times standard deviation. Okay. Decimals, we have this as, okay, I have $70 minus, okay, 2 times $8, which is standard deviation. It was $54. Okay. Okay, $54. And maximum value. So between 2 values with 95% of the data value lies. So it's just the same thing except that here we change this to plus sign. So I'm gonna copy it and put it right here. So we have it here, which is change this to plus. So we have 70 plus 2 times 8. Okay. So we have it, I'm gonna take it to decimals, change the plus. Okay. $86. $86. So let me take it back. Got $86 right here. $86. So that means that it's because the question was asking us between what two values does 90% of data value lies. So that means about, you see that 90% of the bills, okay, of the monthly bills lies within $54 to $86. That means 90% of people in Baltimore City paid between $54 to $86 for their utility. Based on this data set, okay, the actual amount might change depending on the type of data sets we have. Okay, now we answer part A. Part B says, assume that the number of households in the sample is 40%. Is 40. Assume that it's 40 people in the household. Or I'm sorry, assume that the number of households surveyed is 40 households. Estimate the number of households whose utility bills will be between $78 to $94. In this case, you're going to use the chart to get your values for one standard deviation, two standard deviation, and three standard deviation. Then from there, you can estimate the percentage. So, like I said, I'm going to copy this, then paste it here, and then get our values. Okay. So I'm going to copy here. Okay. Let's see if I can copy this each. Okay. Copy this. Okay. Paste it here. It's part B. I think I'm going to copy all of them. Let me copy all of them. All of them. Okay, good. Copy everything. Okay. Then paste it for part B. Part B, solution. So this page will not be enough. So I'm going to move it to the next page so I can have enough room to work. Okay. Yeah. So you copy the pasted some of the things here. Well, so I'm going to, like I say, this is set in stone. So I'm going to just put the lines and then lines here. Okay. Okay. Good. And then here, I think we have what we have there is 2.35%, 2.35%, 2.35%, 2.35%, and then here is something 2.35%. So now, in this case, the only thing that changes the mean. Our mean now is 70, and standard deviation is 8. So our mean here gonna be the middle value is the mean, $70. Now standard deviation is 7. Let me just copy this so I can going back and forth. Mean is 70. Standard deviation is that. Mean is 70 here. So, and standard deviation is $8. So now we can get, let's get numbers for the one standard deviation, two standard deviation, and three standard deviation on the left side. Then one standard deviation, two standard deviation. I think something is missing on the left side. One standard deviation, two standard, and three standard deviation. 1, 2, 3. Okay, 1, 2, 3. Okay, so 1, 2. I didn't put the line for this one. Okay, I'm gonna put it now. Okay, for the three standard deviation should be here. I didn't close it. Okay, I'm gonna close it. Okay. Now, so now we have this. We can now be able to get our values. First one is for one standard deviation. We have left side, I have mean minus one standard deviation, which is $70, which is $70 minus $8. That will give us $62, I believe. And the right side will be the same thing, but we're going to change this to plus sign. Okay, I have it here. Mean plus, excuse me. So I have it here. Plus, so I can get it from my head. This is very clear. It's $78. So that means here we have the left side have $62. 32. Okay. On the right side, we have $78. So we'll repeat the process to get the two standard deviations. For the two standard deviation, if you remember, you'll be using this formula here. Mean minus two standard deviation for the left side, and mean plus two standard deviation for the right side. So let me take you there again, so that we have left side have the mean, okay, minus 2 times the standard deviation, which is the mean of 70 minus 2 times standard deviation of 8. Okay, so I'm gonna write it down. Mean time 70 minus 2 times 8. So I'll have I'll take it to decimals. I will have 70. Okay, I will have it here already. 70 minus 2 times 8 is $54. And for 2 plus 8 plus 2 times 8 will be $86. So I got both of them. So let me take you back here. Take you back here. Share the screen. Okay. Okay. So we have for this song we have $54, and we will do the same thing for the right side. Okay, but changing it to plus sign symbol. Okay, right side, change it to plus sign. Change it to plus sign. The answer we got from the calculator, decimals, is $86. So that means for two standard deviation, we have left side is $54. Okay. Which is the mean. Okay, and the right side is $86. So $86. Now, the same thing again, repeat it for three standard deviations. Okay. Look at for three standard deviations. For 3 standard deviations, we're gonna use the formula for 3 standard deviation again, which is mean minus 3 standard deviation for the left side and mean plus 3 standard deviation for the right side. So mean minus 3 standard deviations for the left side, the right side, mean plus 3 standard deviations. So we'll have it in this form. We repeat the same thing and change this to 3 standard deviation. Left side, put it right here. Left side, but instead of 2, we're gonna use 3 here. And then use 3 here. Okay. Let's see what it will give us from this month. Okay. So I'm gonna have 70 minus 3 times 8. Okay. Taking you to decimals, we have it here. Okay. Change this to minus sign. 3 standard deviation. That gives me 46. And if you change this to plus sign, okay, to plus sign here, to give me 94. So let's go back to our work and finish it. We're almost done. So that we have it here. For this one, we have 46. If we do the same thing, right side this time, right side, and change this to plus 3 standard deviations. The same thing here. As you can see from what we got from the decimals, this will give us 94. So for the left side, we have 46. Okay. And for the right side, we have 94. Okay. Now we have all the numbers. We are ready to answer the question. The question says, assume that the number of households in the sample is 40. Estimate the number of households whose monthly utility bills are between $78 and $94. Between $78 to $94. Okay. First of all, let's get the percentage. Then we can now multiply it with 40 to get the answer. So, percent of households. Let's get the percent. Percent of households with monthly bill of this. Okay. So I have percent of households. Okay. The percent of households whose monthly bill are between $78 and $94 is, okay, 78 and 94. Look at 78 right here. You see right here, this is 94 right here. See, you can see that if I go from here to here, it's 13.5% plus 2.35%. See? So this is from 78 to 94. 13.5% for 78, 2.35% for 94. So 13.5 is going to be 13.5% plus 2.35%. I'll give you the percent of household with utility bills between $78 and $94. That'll be 13.5% plus 2.35%, which we can get from decimals. Okay, 13.5%, 13.5% plus 2.35%, 2.35%, 15.85%. So that'll be 15.85%, 15.85%. Okay. So I'm gonna share this. That'll be 15.85%. 85%. So now we haven't answered the question yet. We just got the percentage because the question says, assume that the number of households is 40. Estimate the number of households whose monthly bills are between $78 and $94. So we just got the percent of household whose monthly bills are between $78 and $94. Now let's use it to multiply the 40 to get the number of households. So since N is 40, right? In this case, N equals 40 households. Okay. So that means that the number of households, the number of households whose monthly bill are between $78 and $4 are 40, okay, times 15.5%, 0.85%. Now, if you're multiplying by percent, of course, you know from your basic math class that you have to change the percent to decimal, which gives us 40 times 0.1585, okay, which is approximately how many households? So let's multiply it in decimals. So we have here, we have 40 times 0.1585. So approximately 6 households. Okay. Approximately 6 households we have the same. So we have, once I got 6.34, 6.34. Okay. 6.34. 6.34 households. We have the utility bills between that values, between $78 to $94. But you know, we don't have how many households? We don't have the 6.34 households, do we? Yeah, of course we don't. So what you're gonna do is to round it. You know, some books will say round up, some will say round up, but go to the I will just say if you round up, you exceed the the boundaries. So I'm gonna just mean equals to 6 households. Okay. So this basically how we use empirical rule. I've shown you 3 examples, basically how to apply it. Okay. And then you can solve as many examples as you can. And of course, I want you to feel free to subscribe to my channel so that you can always be informed when there's a new lecture available. Okay. Questions, if you have any questions, please feel free to email me your questions, and I'll try as much as possible to respond to everyone's email. Okay. Now, I hope you enjoyed the lecture and you have a nice weekend. Okay. Bye-bye.